Welcome back to Maths video tutorials. In this tutorial, we'll be looking at these two questions. The first one being for all integers n, if n cubed minus 5 is odd, then n is even. The second one, there exist no integers a and b for which 15a take away 5b equal 1. So let's jump right into it. Before answering question 1, I'd like to go through this exercise. If n squared is even, then n must be even. We need to prove this statement by contradiction. We need to write down the assumption. So we're going to say, let's assume. So what is the opposite or negation statement? If n squared is even, then n must be odd. That's the opposite or negation. We need to attempt to prove this statement or assumption true based on n being odd. So if n is odd, then we do n equal 2k plus 1, and then we need to square it because we're trying to find out if n squared will be even when n is odd. And that gives us 4k squared plus 4k plus 1. So now the question is this one even or odd? Well, this one is odd because this one is even. The 4k is even also. So basically you're doing even plus even will give you even. But then when you add 1 to an even number, you get odd. So you can see we have arrived to a contradiction, which is n squared would be odd. If n is odd, n squared would be odd. So we need to write down the conclusion. So our assumption is false. Therefore, the n squared is even. Okay, so let's start with question 1 now. So let us begin with this exercise. One thing to notice that this question can easily be done using direct proof. Okay, but we're going to do it using the proof by contradiction in order to gain more practice. So the opposite statement we need to assume will be if n cubed minus 5 is odd, then n is odd. As you can see, I wrote down the assumption, and we're going to base our logical steps on the fact that n is odd. N being odd means we can write it down as 2m plus 1. For example, we could use 2k plus 1 or 2l plus 1, doesn't matter. It has to be in this form. So we need to now elevate n to the power of 3 because our expression is n cubed take away 5. So let's do that. N cubed is going to be, I'm going to put it in bracket 2m plus 1. And we could do this either by expanding the square first, and then the answer time it by itself, I mean 2m plus 1. So this is what you get after expanding it. And now we need to subtract 5 from the expression. So taking away 5 from this expression will give us as minus 4 because 1 take away 5 is negative 4. Let's write it down. I should write down here n cubed take away 5. And take away 5, that gives minus 4. All right. Now you can see all these coefficients are even, so I can factorize this expression. That's 2 outside the bracket, 4m cubed plus 6m squared plus 3m, and take away 2. So that will tell us now that n cubed minus 5 is even. All right. So that's what it is. So that shows that n cubed minus 5 is even, which is in contradiction with the assumption that n cubed minus 5 is odd there. So we arrived to a contradiction, we contradicted ourselves, so now we completed the proof. So therefore we can assume that our assumption is false or wrong. We can make a conclusion now. Say our assumption is false, because remember our assumption is the opposite of the original statement, this one here. So if it is false, then the original statement has to be true. So then the original statement is true. Okay, let's move on to the next exercise. Welcome back to this tutorial, and in this part we are answering this question, which asks us to prove the statement that there exist no integers a and b for which 15a minus 5b equal 1. So we're gonna start by assuming the opposite is true. Let's assume there exist, because the opposite no integers is there exist integers a and b, for which, of course, the rest is the same. 15a minus 5b is equal to 1. So you can see 5 is a common factor, so we're going to divide by 5. So that will give me 3a minus 5b divided by 5, that's going to be b. And 1 divided by 5 is 0.2 or 1 over 5. I'm going to keep it as a fraction. Now this one here, 1 5, is not an integer. Is not an integer. So this is a contradiction. So this is a contradiction. Of our assumption. So therefore we can make a conclusion straight away. Our assumption is false. So therefore the original statement is true. Okay, and that's how you do this one. I hope this video tutorial has been helpful in help you understand and how to proceed with proof by contradiction. Thank you for watching and take care.